Okay, Shabab, today we'll start by our last section in this course, which is section 3.6. We will talk about rational functions. Now, in this section, we will define the rational function. Then we will graph the transformations on the function y equals 1 over x. Then after that, we will introduce the definition of an asymptote of a rational function. And after that, we will graph the rational functions. This is what we will do today. Next time or the next lecture, we'll talk about the common factors. If we have a common factor between the numerator and denominator, what will this affect our graphs? So let's first of all define a rational function. A function f of this form, f of x equals p of x over q of x, where p of x and q of x are polynomials, of course with q of x is not zero, is called a rational function. So when I say rational function, it means I'm dividing a polynomial by another polynomial. This will give me the rational function. And of course, as we mentioned, the denominator should not be zero. Now look at the first example that I wrote, f of x equals 1 over x. If I ask now, 1, is it a polynomial or not?
Yes.
I think yes. Is x a polynomial?
Yes.
If you remember, the definition of a polynomial was the powers of the variable should not be or should be non-negative integers. And is it division between 1 and x or not?
Yes.
So this whole thing, what do we call it? A rational function. Now let's look at the second example. X plus 1, is it a polynomial?
Yes.
The answer is yes. 3x minus 4, is it a polynomial also? The answer is yes. So are we dividing them or not? So since we are dividing a polynomial by a polynomial, what do we call this? A rational function. Now let's talk about the graph of y equals 1 over x, or f of x equals 1 over x. This is our function now. F of x equals what? 1 over x. Now to graph it, I will make a table of values, and in my table, I will choose some values for x. Here I chose these values that you can see in the table. Now, if we replace x by negative 2 here, Shabab, 1 over negative 2 is what? Is negative half. And if I replace x by negative 1, 1 over negative 1 is negative 1. And the third value for x is negative half. If we replace x by negative half, we have 1 over negative half. How much is that? It's negative 2. Type, can I replace x by 0? If I put 0 for x, what will I have? 1 over 0, which is? Undefined. Now let's replace x by positive half. 1 over positive half is what? Is 2. And if I replace x by 1, 1 over 1 is 1. And if I replace x by 2, 1 over 2 is half. Now let's try to plot those points. Negative 2 with negative half. If I plot it on my graph, it will be this point here. Then our next order pair is negative 1, negative 1. Then we have negative half and negative 2. Then we have 0. We cannot draw it, of course, because it's undefined. The next order pair is half with 2. And the next order pair is 1 with 1. And the last order pair is 2 with half. Now you can see we cannot make one curve for these points, which means we have to make two curves. So our graph of f of x equals 1 over x is made of two curves, as you can see. Now let's look at this line, Shabab. This green line, Shabab. Is it horizontal or vertical?
Horizontal.
This is horizontal. Now, my curve, look at the curve now. Is the curve intersecting this horizontal line? If we extend the curve, does it intersect the horizontal line, which is y equals 0, or not? Yani my question is, can the value of 1 over x be 0? Can 1 over x be 0?
No.
So this means my curve will not intersect this horizontal line, but it will keep getting closer and closer. If I take a larger value for x, what will the value of y be? If I replace x by 100, let's say, replace x by 100 in the function. What's the value of y? 1 over 100. It's a very close number to what? To 0. And if I replace x by 1000, I will have 1 over 1000, which is again closer to 0. But will my answer be 0?
No.
The answer is no. So my curve here, as x gets larger, the value of y is getting closer to 0. So my curve is getting closer to the x-axis, but it will never touch the x-axis. In this case, we say that the x-axis is a horizontal asymptote. Asymptote خط تقارب. And in math, what does it mean? That the curve will keep getting closer and closer to that line, but it will never intersect that line. Also from the left side, Shabab, if you look at the left side, if I put a very large negative value for x, let's say negative 1000, will the value of y be 0 or very close to 0?
Very close.
Very close to 0 means again my curve will not intersect the horizontal asymptote. طيب. We have also another asymptote, which is this yellow one. This yellow line, Shabab, what is it? Is it the y-axis or not?
Yes.
طيب. Do you know what's the equation of this y-axis?
X equals
X equals 0, I think. This is the equation. Now, as x gets closer to 0, what will the value of y be? Yeah, if I say 1 over 0.01, what's the answer for this? I think it's 100. But if I say 1 over 0.001, the answer is what?
okay.
So as x gets closer and closer to 0, what will happen to the value of y, ya Shabab? It will be very large. It will go to where? To infinity. Which means my curve, look at the curve now, as we are approaching the y-axis from the right side, the curve is going where? The curve is going to infinity. Does the curve intersect the y-axis?
No.
The answer is no. In this case, we say the y-axis is a vertical asymptote. Again, asymptote, what does it mean? We said خط تقارب. So this function that we are drawing right now, it has two asymptotes. A horizontal one, which is y equals 0, and a vertical one, which is x equals 0. Of course, from the graph, we can know that the domain is what? All real numbers except 0. And the range is also all real numbers except 0. Now, our graph, Shabab, is it made of one curve or two curves? Two curves. Now, these two curves, they are not connected, right? So we say there's a discontinuity. Discontinuity means نقطة عدم اتصال. Discontinuity at what? Where is the discontinuity?
0.
At x equals 0. طيب. Now, is my graph increasing or decreasing? Look at the piece to the left side piece. Is it increasing or decreasing?
Decreasing.
I think it's decreasing. The decreasing in the left piece starts from negative infinity to 0. And in that second piece to the right, is my curve decreasing or increasing? The second piece to the right.
Decreasing.
It's decreasing from where to where? Also from 0 to infinity. Type. Now, is this graph symmetric about anything, ya shabab? Look at the graph. Is it symmetric about anything? About the x-axis or the y-axis or the origin?
Origin.
Yes.
This is symmetric about the origin. And if you remember, the meaning of symmetric about the origin is what?
Change.
If we rotate the graph 180 degrees, rotate, what does it mean in Arabic? Rotate.
دوران.
Dawaran. If we rotate the graph 180 degrees about the origin, it will give us back the original graph. So this graph is symmetric about what?
Original.
About the origin. And if you remember, symmetric about the origin, what does it mean? That the function is odd. Remember that? Odd functions are symmetric about the origin. Even functions are symmetric about the y-axis. So this function, which is 1 over x, y equal 1 over x, is symmetric about the origin, which is odd. Any questions about the graph of f of x equal 1 over x? You can raise your hand. Okay. Now, this is the mathematical definition of the asymptote. And we said asymptote, what does it mean in Arabic one more time?
خط التقارب.
خط تقارب. Now, Shabab, if you look at this graph here, in this yellow part here, the values of x are going where?
Infinity.
Going to infinity. Where's the value of f of x going to?
0.
To 0. So that we say it's a horizontal asymptote. Type. In this blue part, where is x going, ya shabab? In the blue piece. X is going to negative infinity, and the value of f of x is going also to where?
0.
To 0, because the curve is getting closer and closer to the x-axis. Now let's look at the green part here. Where is the value of x going to? The value of x, not y. In the green one, where is x going to?
0.
X is going to 0, but from the right side. This plus on top of 0 means 0 from the right. And if x goes to 0 from the right, where is the function going to? To infinity. If we go now to the last piece below, in the last piece below here, where is the value of x going to? The value of x. The value of x is getting closer to 0, but this time from where? From the left side. So this here is 0 to power negative. This thing means what? 0 from the left side, which means the values of x are negative. Where's the function going now? To negative infinity. So these are the definitions of the horizontal and the vertical asymptotes. Again, in my next slide here, you can see the definition of the vertical asymptotes and the horizontal asymptotes. The definition of a vertical asymptote, what does it mean? Again, as x approaches a number, a real number, the value of y goes to infinity. Or as x goes to a number from the left, y goes to infinity or negative infinity. Here in the first case, I'm talking about as x goes to a, y goes to infinity. In the right side, as x goes to a, the value y is going to where? To negative infinity. So all these are called horizontal asymptotes. As x approaches a number, the value of y is approaching what? Infinity or negative infinity. All these are vertical asymptotes. Now we have the mathematical definition of definition of a horizontal asymptote. What's the mathematical definition of that? As x approaches infinity now, not a number, or negative infinity, the value of y is approaching a real number. This is a real number. So as you can see in the vertical, x is approaching a real number. Then the value of y is approaching infinity. But in the horizontal, y is approaching a real number as x approaches infinity. Now, in regarding the horizontal, Shabab, in some rational functions, rational functions sometimes can intersect the horizontal asymptote, but in the middle, not on the edges. Edge, what does it mean? الأطراف. So at the edges, the horizontal asymptote does not intersect the curve, but in the middle, sometimes, in some cases, the curve can intersect the asymptote. After all this introduction, let's start graphing some basic functions. Look at this graph. He says what? Graph the function f of x equals 2 over x plus 1. First of all, Shabab, if we remove the 2 and the 1, what's my remaining function?
1 over
Removed 1. 1 over what?
x.
1 over x. And we should remember how to graph that one. We did the graph earlier, right? So let me just bring the graph and put it in the notes. The same as the ones that we did earlier. This is the graph of what now? I'm just going to plot it here. This thing is the graph of what now?
1 over.
1 over x. Now, this graph, Shabab, of 1 over x is multiplied by 2. Do you see this 2? Is it multiplied by 1 over x or not? And the plus 1 is added to x. Now we have to remember what's the meaning of these in the graphing techniques, in the transformations, if you remember the transformations. So now this 2, what does it mean, Shabab? Am I multiplying the function by 2 or am I multiplying x by 2 here?
Function.
The function by 2. So what does that mean if I multiply a function by 2? Remember the transformations? Is this a stretch or a shrink or what?
Y multiplied with 2.
So this is what we say, this is a vertical stretch. And what does it mean, vertical stretch? It means I have to multiply the values of y on the curve by 2. Let's take some values for y. I will just pick 2 order pairs, 1, 1, and I will pick the order pair negative 1, negative 1. What should I do to the values of y here?
Multiply by 2.
I have to multiply them by 2. So let me multiply. If I multiply them by 2, what do we get?
2 and negative.
I will get 2 order pairs. My first order pair will be 1 and 2, and the second order pair will be what?
Negative 1 and negative 2.
Negative 1 and negative 2. So let me plot these here. This is my second graph of what? This second graph, you can see that the values of y have changed. Look at the values of y. What's the order pair that I'm plotting here? This order pair, the red one, Shabab, is what? 1 and 2. And this order pair is negative 1 with negative. So what did I do to the values of y here? I multiplied them by what?
By 2.
By 2, because this is a vertical stretch. So the first graph is y equals 1 over x. The second graph is y equals 2 over x. Now the plus 1 here in the denominator, is it added to x or to the function?
Function.
So what does that mean in the graphing techniques?
got left.
It's a shift what? Left. How many units?
1.
Now, if I shift it to the left, Shabab, will I change the values of X in the order pairs or the values of Y?
Value of X.
So here, the values of X, what are they? I have 1 and -1. If I shift to the left 1 unit, what will the values of X be?
0 and -1 and -2.
Thank you very much. Let's plot these now. Now, do we have a vertical asymptote in our graph? What's the vertical asymptote in our graph?
0.
The basic one. Now, this vertical asymptote, what's the equation of this vertical asymptote? It's x equal what? X equals 0. If I shift this to the left, because this is a value for x, if we shift it to the left, what will my new asymptote be?
X equal 1.
-1.
Negative 1.
-1, not 1, because we are shifting to the left, not to the right. So this will be our graph here. Let's look at the order pairs. Let me just put this in a proper position. Let's look at the order pairs now here. What's the order pair that I'm plotting right now? This one. It's 0 with 2. And the order pair that I'm plotting right now is... So what has happened here? What did I do? I have shifted the graph with 1 unit to the left. This green line, Shabab, it was the vertical asymptote, am I right?
Yes.
Where did this asymptote go now in my last graph?
It shifted.
It has been shifted when to the left. So this last graph is my graph of y equals 2 over x plus 1. Do you have a question about this graph? Fine. What's the domain of my graph, ya shabab? Yes, Ahmed Abdel Khaliq, you are raising your hand.
Yes, why vertical stretch?
Because we multiply the function by 2. If I say 1 over x, if I multiply 1 over x by 2, do you know what's the answer?
2 over X.
2 over x. So this 2 over x, what does it mean? I have multiplied the function by 2. And if I multiply the function by 2, this is a vertical stretch. Okay?
Okay.
طيب. For this last graph, Shabab, what's the domain? All real numbers except
-1.
-1. And what's the range?
All the numbers
0.
Except 0. Now, if I look carefully, where's the vertical asymptote in my last graph? The vertical asymptote, where is it in the last graph?
X equal -1.
Thank you. It's x equal to -1. Is there a relation between this equation and the 0 of the denominator? What makes my denominator equal to 0?
-1.
So can I give a rule now that the 0 of the denominator is the vertical asymptote?
Yes.
Yes, it is. Also, my domain will be all real numbers except the 0 of the denominator, and we all know this. Type. Do we have a horizontal asymptote in this graph?
Yes.
Where's that horizontal asymptote?
Y equals 0.
Y equals 0. Thank you. So this thing here, does it have any relation with this range? Look at the range, Shabab. So can I say my range is all real numbers except The value of the horizontal asymptote. So we say the range is affected by the horizontal asymptote and the domain is affected by the vertical asymptote. Any questions? طيب. Now, in the vertical asymptotes, we took the case. We said the vertical asymptotes, how can I find them? Again, I will repeat here. Are my vertical asymptotes, are they the zeros of the denominator or not?
Yes.
Yes, but the horizontal asymptotes, now we will learn a rule to find them. And let's read this rule. What does it say? First of all, is this function a rational function or not?
Yes.
That. Since it's rational, how can I find the vertical asymptotes? We said the vertical asymptotes are what?
Zero.
The zeros of
Zero.
the denominator. What makes the denominator zero will make a vertical asymptote. But now, regarding the horizontal, we have three cases. Now, can anyone answer me what's the degree in the numerator?
N.
It's n. What's the degree in the denominator?
M.
It's m. Now we have three cases for the degrees. The first case, if the degree of the numerator is less than the denominator. In this case, Shabab, we say that the horizontal asymptote is y equals 0. Now we have a second case if the degrees are equal of the numerator and denominator. And if the degrees are equal, this is the important case, Shabab. We say the horizontal asymptote is what? Read this statement. Our horizontal asymptote will be, Shabab, an over bn. What's an? It's the leading coefficient of the numerator, and bn is the leading coefficient of the denominator. So if the degrees are equal, I divide the leading coefficient by the leading coefficient. And the last case, if the degree of the numerator is more than the denominator, we say this one has no horizontal asymptote. In this case, we have another type of asymptote. We call it slant asymptote. Slant means ma'il. So let's repeat again. How can I find the vertical asymptotes? The first rule, vertical asymptotes are the zeros of the denominator. How can I find the horizontal asymptotes? We have three cases. If the degree of the numerator is less than the denominator, the horizontal asymptote is y equals 0. And if the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote will be y equal the leading coefficient of the numerator dividing by the leading coefficient of the denominator. And the third case, if the degree of the numerator is more than the denominator, we say this rational function has no horizontal asymptote. Let's take an example to understand this rule. Let's read this one. What does it say? For each rational function, find its horizontal and vertical asymptotes. I will start by the horizontal asymptote now. Now we need to answer this question. Which degree is larger, the numerator or the denominator, or are they equal?
Equal.
If they are equal, Shabab, you see the rule, the second rule on top? I have A, B, and C. Which rule of these should I use? B. So how can I find my horizontal asymptote? I will say y equals what?
Leading.
The leading divided by the leading. And how much is that? 3 over 2. So this is our horizontal asymptote. Regarding the vertical asymptote, how can I find my vertical asymptote?
Zeros of denominator.
Thank you very much. Read number 1, Shabab. The rule on top. The vertical asymptotes are the zeros of the denominator. So I will say x equals what? What makes my denominator 0?
Negative.
over 2.
Negative.
So I will say x equal negative half is my vertical asymptote, which is what again? The 0 of the denominator. If you have a question on any of these two, raise your hand and I will answer yours. طيب. Nothing, I'll move to the next example. Here again he's asking me about the horizontal and the vertical asymptote. But now I will just name the horizontal asymptote as HA. H means horizontal and A means asymptote. How can I find the horizontal asymptote? Are the degrees equal here or not on the numerator and denominator?
Yes.
So we have again to divide what? The leading by the leading. If I do that, what's my answer?
Negative.
Negative 2 over 1, which is negative 2. Regarding the vertical asymptotes, how can I find them?
Negative 3. The 0 of the
X equal, I have to say x equal. X equals what? Negative 3, which is what? The 0 of
Denominator.
the denominator. Of course, right now we are just taking linear function divided by linear function. I want each one of you now to do the third one, Shab. Find the horizontal and vertical asymptote for the third one. Yeah. HA means horizontal asymptote and VA means vertical asymptote. طيب. Ahmed Abdul Khaliq, can you give us the horizontal asymptote? What is it?
Horizontal, no horizontal, no asymptote.
No, let's read the rule now. Go back to the rule. Read the first line in number 2.
N less than M.
Then,
Horizontal asymptote Y equals 0.
so what does it mean n and m? N is the degree of the numerator and m is the degree of the denominator. So if the degree of the numerator is less than the denominator, what's my horizontal asymptote?
Y equals 0.
So in this case, what's the degree of the numerator? Is it less than the denominator or not?
Less 0, right?
So the horizontal asymptote is y
Zero.
equals. Thank you. طيب, Abdulaziz Al-Amri, can you tell us about the vertical asymptote?
X equal 2
Thank you. How did we find that?
اللي هو أصفار المقام
0 of the denominator. So I can say that 2x minus 4 is 0. This means x is 2. This is our vertical asymptote. طيب, let me add one more example here, which is this one, number 4. I will write it now and I want you to do it. I have x squared over x minus 1. Find the horizontal and the vertical asymptote. Now, what can you tell me about the degrees? Who has the larger degree? The horizontal, sorry, the numerator or the denominator?
Numerator.
And we have to go back and read the rule. طيب محمد الحارثي, can you tell us about the horizontal asymptote?
The first or the second?
Horizontal asymptote.
I think one.
Let's go and read the rule again. Read the last one or part C. Read part C. Can you read
If
part C?
n yes greater than m, then R has no horizontal symmetry.
N is the degree of the numerator and M is the degree of the denominator. So here, do we have this case that the numerator has a degree more than the denominator?
No.
What's the degree of the numerator here?
2.
And the degree of the denominator?
1.
So is 2 greater than 1 or not?
Yes.
So in this case, what do we say? Can anyone help us here?
Yes.
No horizontal.
There is no horizontal asymptote here. Why?
Because the power of
The
numerator.
greater than upper than.
The degree of the numerator is more than the denominator. So now I just gave you the 3 cases here. In the third example, the degree of the numerator is what? In the third example. What's the degree in the third example?
1.
No, the numerator is the degree is 0. And the denominator, what's the degree?
1.
And if the degree is less, I use what? Y equals 0. And if the degree is greater, we say no horizontal. And if they have equal degrees, as you can see in part 2,
Yes.
we say what?
Leading operation.
Leading over leading. So these are the 3 cases for the horizontal asymptote. But regarding the vertical asymptote, it's always the zeros of the denominator. Can you tell us, yes, sir, what is the vertical asymptote in number 4?
Yes, 1.
No, you have to say x equal 1. Again, which is what now? The 0 of the denominator. Okay. Now, after this discussion, we will learn how to graph a rational function in a fast way, not using the graphing techniques. If you remember here, which method we have used to graph this example? We used the graphing techniques, which is the transformations. But now we will learn a new method to graph the rational functions. How to graph them? The steps are written here. To graph a rational function, first of all, we will factor the numerator and the denominator. Why? Because sometimes we can simplify. The second thing we'll do is to find the intercepts, which are the x-intercept and the y-intercept. And we have to remember the x-intercept, we have to replace y by 0. And for the y-intercept, we replace x by 0. Now, the next step is to find the vertical asymptotes, then the horizontal asymptotes, then we sketch our graph. Let's take an example how to do this. Look at this example. He says the graph. The first thing we should do, as I said, is to factor. Can I factor the numerator here? Of course, the answer is yes. But if I factor now, Shabab, can I simplify this one? Cannot be simplified. So factoring did not help me in anything here. So I did the first step. The second step is to find the intercepts. So I have to find the x-intercept first. X-intercept, if you remember, we have to replace y by 0. So I will say 0 is equal to what now? 4x minus 2 over x plus 1. If we cross multiply, can I say that 0 equals to 4x minus 2? So this means that the value of x is what now? Is it half or not?
Yes.
So my x-intercept is half with
0.
0. The next step is to find the y-intercept. We have to replace x by 0. So what will the value of y be here?
-2.
Negative 2 over 1. So can I make an order pair from that, which is 0 and negative 2? This is my y-intercept. Now the fourth step, Shabab, is to find the horizontal asymptotes and the vertical asymptotes. Now, Ali al-Gharyafi, can you tell us what's the horizontal asymptote in this function?
Y equal 4.
That's right. How did we find that?
4 over 1 equal 4.
Thank you very much. Taqi, can you give us the vertical asymptote?
Yes, I can. And the vertical asymptote equals x minus 1.
X equals minus 1. Thank you. Now, I will plot my information here on a graph. Let me just bring the coordinate plane now so that we can draw whatever we need. Okay, this is the coordinate plane. Now I will plot it here. And let's put all the information that we have found on this graph. Let's start by the first thing that we have found. We found the x-intercept. What was the order pair for the x-intercept? Half with 0. And we are plotting it here. Then what was the y-intercept? 0 with negative 2. Now let's draw the asymptotes. The vertical asymptote was y equals, sorry, the horizontal asymptote was y equals 4. So let's plot it here. This is our horizontal asymptote. What's the vertical asymptote now? X equals negative 1. We plot it here. Now pay attention for the coming part, Shabab. I have to draw how many pieces for my graph? If you remember the graph that we did here, how many pieces were in this graph, the last one?
2.
2 pieces. And those 2 pieces, if you see, Shabab, they are not adjacent. Adjacent in Arabic means mutajawir. So my 2 pieces are not adjacent. This is important if you have a linear over a linear. So if I go to my graph now, how many pieces should I draw? I have to draw 2 pieces. I will start with the piece that passes through the intercepts. Here, I will make the graph passing through the intercepts, and at the same time, it's getting closer to the asymptote, but of course it's not touching the asymptote. So this is our first piece. Now, where should I draw the second piece? Should I draw it here?
No.
No.
Why not here? Because they should not be adjacent. Should I draw it? next to it here? Also, the answer is no, because these again are adjacent. I can draw it in this place. The answer is yes. But now, if you want to be more accurate, you can take a point or a value for x which is less than -1. Can I take a value for x less than -1? Let's say -2. What will the value of y be if x is negative? Substitute -2 on top.
-8.
-8.
-10.
I think the answer will be 10.
Yes.
10.
So -2 with 10, it will be somewhere here, yeah. 10 is, let's say here, a point -2, 10 will be somewhere here. So the graph will be like this. So as you can see, as we mentioned earlier, the two pieces should not be adjacent. Now from this graph, Shabab, can anyone tell me what's the domain?
All the numbers except -1.
Except -1. And the range?
All the numbers except 4.
All real numbers except 4. So again, I will repeat, what were the steps that I have used to graph? The first step, I have to factor, because sometimes we can simplify. The second step is to find the x-intercepts. Third step, find the y-intercepts. The fourth step, find the horizontal and vertical asymptotes, then put all these together in my graph. But don't forget, the two pieces of my graph should not be adjacent. And this is only true if we have a linear divided by linear. Any questions? Let's take one more, which is this one. Again, he's asking us to graph. The first step is to factor. Can I factor anything here?
No.
So I will just move quickly to what? To the x-intercept. How can I find the x-intercept? I have to replace y by
0.
And if I do that, what will I get? 0 equals to what?
2x minus 3.
If I cross multiply, I'll have 0 equal to 2x minus 3. So how much is x?
3 over 2.
3 negative 3 over 2.
So the 3 over 2 and 0 is my x-intercept. Now, can you make a relation? Is my x-intercept, is it the 0 of the numerator or not? So I can make this as a rule, that my x-intercept is what? The 0 of the numerator. What about the y-intercept now? We have to replace x by 0. What will our answer be?
-3.
-3.
-3 over 1, which is -3. And so what's the
0
order
and
here?
-3. 0
Will
and
be
-3.
0 and -3. Now let's go and find what then? The vertical asymptotes and the horizontal asymptote. What's my vertical asymptote here? Can
-2.
Ahmed Al-Harbi, give us the horizontal, the vertical asymptote.
Yes, it's 2.
No, it's not 2.
The vertical asymptote is 1
1, which is
of the denominator.
طيب. Now we need Muhammad Al-Galaf to give us the horizontal asymptote.
Yes, it is -2.
Thank you. How did we find that?
The coefficient of the leading coefficient.
Thank you very much. Now we plot all these in our graph. Again, let me just bring the graph so that we can start plotting. Okay, we have y equal -2 and the vertical is x equal 1. Let me bring it here. This is our graph now. Let's start putting the things that we have found. First of all, 3/2 and 0, it's on the x-axis. Then we have 0 into 3 on the y-axis. Then we have x equal 1, which is the vertical asymptote. And we have also what our horizontal asymptote is, y equals -2. It's here. Now again, I should draw two pieces, but now Shabab, if you see, my x-intercept and y-intercept, are they on the same side of the asymptotes or on different sides of the asymptotes?
Different.
Different sides means what? That each intercept will be on a different part of the curve. Of course, to start the drawing now, I will draw my first piece here, passing through the y-intercept, and at the same time it's getting closer to the asymptotes. And the second piece will pass through the x-intercept, but again, don't forget, it will get closer to the asymptotes. And as you can see, the two pieces are not adjacent. If you have a question about the graph, raise your hand. We'll stop here today. Continue our lecture next time.